Hello, my name is Talhaza here, and my culminating task is to determine the exact length in terms of k of the largest rectangle that can be inscribed inside a semicircle with a radius of k units. I'll have to place the length of the rectangle along the diameter. So the first step would have to be to draw the diagrams. So the first diagram, we're just going to draw a semicircle like that, and a dotted line to indicate that there's a line here. Then we're going to place the rectangle inside, like such. And look at that. If you connect the points here, you can see that there's right angles right there. Not really too important for this, but pretty neat. I'm also going to make a second diagram with just the rectangle and some excess, so we can like clearly define what it is, or define our variables, and it'll just make it easier to read. Also, if you notice, I'm not doing like Pythagoras' theorem, like I'm not making these straight. I know there's a curve to it, so that would be incorrect if I used Pythagoras. Let's put some variables on here. We know that the radius is k, so we can just say the diameter is 2k. But if you notice, we can't just say that this length is 2k as well. We're going to have to say that we're going to have to name this length and this length. And these two lengths are the same because it's a circle and it's a rectangle. It's common sense that these two lengths would be the same. I'm just going to name this a random variable, like variable j, right? And now that we have this, we can say that the total 2k subtract 2j would give us the length of our side over here, which is the same as that. We also have a width that's the same, but we're not calculating for the width, we're calculating for the length, so that's not too important either. And just for a little added detail, this entire thing is equal to 2k. Second, we're going to need some formulas. We can't just calculate with two diagrams. We know that the area of a rectangle is their length times their width. And we know that the perimeter of a rectangle is similar in style, 2L plus 2W, 2 lengths times plus 2 width. We have the area of a semicircle, which would be 2 pi r. Oh, no, not 2 pi r. Pi r squared, I meant. Over 2. And we have the circumference of a circle, 2 pi r. The perimeter of a semicircle, that's essentially circumference, except since it's a semicircle, it's not technically a circumference, even though it technically is, but not really, because that's straight line underneath. And just in case we need it, we'll have the area of a circle, which would be pi r squared. And we can also, we can actually rewrite these. So this would be pi times k squared. Same with this, k squared, k, and then k and k. Because we have the variable for it. The third step would be to solve for, let me focus, okay, there, for k. These were the formulas. I'm going to use the perimeter of the semicircle first. This is probably the easiest way to solve for R or K algebraically. So actually, or at least in my opinion, this is the easiest way to solve for K. We can, so this is essentially P times K. We can rewrite this as K times pi plus 2. Then we can say that pi times K squared over 2, which is the area of the semicircle, is equal to the perimeter of the semicircle, which would just be K pi plus 2. Next, we'll just solve for this. So we're going to divide both sides by K. So it would end up being pi K over 2 equals pi plus 2. And then we can just easily solve for K, 2 pi plus 2 over pi. And now we have our first actual equation. I'm actually going to write 2 times K as well, which would just be 4 pi plus 2 over pi. Because you're just multiplying the numerator by 2. And now we're going to solve, we're actually going to calculate the area of the rectangle as well. Rectangle. So we area of the rectangle, fourth step. And the area of the rectangle would be pi r squared over 2, which is the area of the semicircle, pi k squared, I mean. And we subtract, we add it 2k minus j, which is actually 2k minus j would just be this 2k minus j. Then just to have it in the same fraction, we can say pi k squared plus 4k minus j over 2. And then we're going to solve for k again. We'll have 2 different values for k, which will allow us to solve for j as well. For k. So the area of the rectangle equals pi r squared plus 4k minus j over 2. And how we're going to solve for k is by using the derivative. And then we're going to make the derivative equal 0 afterwards. So derivative of d would be pi r squared plus 4k minus j over 2. We're going to have to do the add the constant in front, and then we can do this. Here you go. Pi k squared plus 4 d over. Okay, so here's that. Simplifying / solving would give us 2 pi k minus 4. And then if we simplify even further, the derivative is equal to pi k minus 2, I mean. Setting this equal to 0 would give us pi k minus 2 k equals 2 over pi, which is different from our k over here. Very slightly, minute difference, in fact, but it's enough to change the whole formulas or equations. So now we can solve for j, and the method we're going to use is the total length of the semicircle-ish is 2k, and the length of our rectangle is 2k plus, or 2k minus 2j. So now you can see why we needed two different k values. Which equals 4 pi plus 2 over pi minus 2j. Get them in the same fraction, so far pi over 2 minus 2 pi j over pi, because you have to multiply 2 times j by the fraction pi over pi to get them into the same fraction. Then we can say that k, in the same line, we can divide both sides by 2. So we can just say, simply say this. And now that we have k on its own, we can substitute it for 2 over pi. And we can simplify 2 pi by dividing both terms by 2, because it's easily divisible by 2. And so we can just say 2 pi plus 2 minus pi j over just pi this time. Then we can multiply both sides by pi, remove the denominator from each. So now we have 2 pi plus 2 minus pi times j. And we can, just because I don't have any room, I'm just going to quickly simplify j to 2 minus 2 to the power of plus 2, or pi plus 2. I don't know where I got power from. Over negative pi. Essentially what we did here, we just subtracted both sides by 2 pi plus 2, giving us 2 minus 2 pi over 2, but we had a negative pi over still connected to our j, so we divided both sides by negative pi as well. Lastly, we're going to simplify the length, because now that we simplify, because the length of the rectangle is 2k plus 2j. And since we have both k and j already, we can now, we could technically end the question right here and just substitute both k and j, but it would give us a very large unpleasant answer, so we might as well just simplify. And so 2k plus 2j, or because the length of rectangle is 2k plus 2j, 2k plus 2j is equal to 4 times pi plus 2, because that's, as we saw from here, 2k is equal to 4 pi plus 2, or 4 times pi plus 2 over pi. And I'm actually going to switch the negative from here, negative pi, over to the numerator, so that way the denominators can be the same. So I'm just going to have to multiply this second term by a fraction of -1 over -1, which would give us negative. And since we're also multiplying it by -2, or multiplying it by 2j, we can just put the negative sign in front of this 2 instead of the actual equation, which would give us 2 minus 2 pi plus 2 over pi. We're going to expand these terms and add them into the same fraction as well. So 4 pi plus 8, it would give us 4, this would give us 4 pi plus 8, add the -2 times -2 pi minus 2 over pi. So we have like that. Then we have 4 pi over 4 pi plus 8 plus 4 pi, because -2 times -2 pi is 4 pi, plus 4, giving us 8, oops, forgot the pi. So this would give us 8 pi plus 12 over pi. 12 over pi, if we wanted to simplify this even further, 12 over pi plus 8 would give us 2k plus 2j, which is the length of the rectangle. And we weren't asked for the width, so we're just going to solve for the length of the rectangle, which we have, 12 power 8. So our therefore statement would say the length of rectangle is 12 pi plus 8. I already solved for it. They wanted an exact value, but I'll approximate it to 11.8 units since I've already given them the exact value. 11.8 units approximately as well. But yeah, this is our length. Thank you, and goodbye.